Hi guys, in this question we are going to take a look at the maximum rate of change of a given function at a specific point on the surface. So I want to first geometrically explain what is the maximum rate. So let's go ahead and just define the surface. So this is y and e to the power 1/4 xy. Okay, so this is the way the surface looks like, but we want it at specific point. So we want it at 0, -1. So it allows me, the CalcPlot3D applet, which is a wonderful applet, allows me to see the situation, visualize it at that specific point. So I'm going to use this 2D trace plane to do that. And I'm going to enter 2 and, oh, I think it was 0, sorry, 0, -1. Okay, so that's the point, and you can see that this is the blue point on the surface. So the question is, in which direction should we travel so that the directional derivative of the, or the rate of change, or the slope of the tangent line is as large as possible? In which direction should we travel? And the tangent line, by the way, is the to the trace of the surface in that direction. Now, how do we do that? How do we visualize it? So we have this little menu, and it allows me to actually compute the gradient at this point. So I'm just going to click on show gradient at point on surface, and it shows me the gradient as the red arrow. And it also gives me the value of the gradient. So we know from theory that the maximum rate is equal to the magnitude of the gradient at that point. Well, what is the magnitude of the gradient? 0.25 and 1. Okay, let's compute that. That would be square root of 0.25 squared plus 1 squared, right? So this would be 1.03. So what the theory is saying is, if we go in this direction, the directional derivative or the slope is going to be 1.03, and nowhere else, none other direction can give us a larger directional derivative. Well, what if you don't believe me? So what you could do is go to again to this arrow and use show directional derivative trace. So I use that. Now, at this point, the direction is looks like to me is at a pi over 4, 45 degrees. So the green arrow shows you which direction is currently this directional derivative is computed at. And the red arrow shows the gradient. And what we want to know is, can we make this directional derivative larger than this 0.88? Because remember, we figured out that the magnitude of the gradient was 1.03. So if we were to try to change the direction, and so that the green arrow, which is the current direction, and the red arrow, which is the gradient, if they coincide, then the directional derivative should be as large as possible. So what I do is I right click on this green vector, and then now I see the red vector, which is the gradient, and I'm going to try to move the green vector so that it coincides with the red. And notice how the directional derivative starts changing and increasing, but when the green and the red vectors are the same, see how I got them to be as close as possible. The directional derivative is now 103. And nowhere else, no matter where I will be, I will never get anything larger. So the gradient shows you which direction to go so that it's as steep as possible. There is no other direction as steep. Okay, so hopefully you understand the geometry of it, but now let's see how to compute it, because it's actually a good exercise, because we're going to need the product rule here. So let's see. So this is our f of xy, and it is equal to y e to the power 1/4 xy. And again, the point is 0, -1. Now, the first thing to do is compute the partial derivatives, and those are going to be the components of the gradient. So first, let's compute the partial with respect to x. That one is a little bit easier. Now, we are multiplying two things. So we are multiplying y, and then we are also multiplying e to the power, right? All of this stuff. Okay, now, when you take the derivative with respect to x, y is a number. So we can use the constant multiple rule, and we do not need product rule here. So we're just going to keep the y here, and then we multiply by the derivative of e to the power 1/4 xy. Now, e to the power This is something that for one variable is supposed to know. So that e to the power ax derivative is a e to the power ax. Okay, so you should know that. But what is a in this case? So anything that doesn't have x is a. So in this case, it'll be 1/4 y. So this 1/4 y is going to go to the front, and then we multiply it by the same e to the 1/4 xy. So this part and that part, the part that has no x, that's our a in this case. Okay. Now y and it looks like it's another y that you can actually convert it to y squared. So this will become 1/4 y squared e to the power 1/4 xy. Okay, now what about the y derivative? That one we do have to use product rule. And the reason why is because both y and e have a y in them. So you do need the product rule. You can't use constant multiple rule. So what does the product rule say? It says take the first function, take the derivative of it with respect to y. Well, that's just going to be 1. Multiply it by the second function without change. Plus, take the first function, which is y, and multiply that by the derivative of the second function. And what that would be, now think I'm taking the derivative with respect to y. My a now is everything that doesn't have y, which is 1/4 and x. So that's going to jump to the front, and then I'm going to have the same e. Okay, so that's the y derivative. So this is going to be e to the power 1/4 xy plus 1/4 xy e to the 1/4 xy. Okay, so I just reordered the terms a little bit. All right, so that's the gradient. The next thing is to go ahead and find, I don't know why it didn't submit. Okay, plug in the point 0, -1 into the gradient. Let's see, because you wanted that specific point. Okay, so 0 we plug in for x, and e to the power 0 is just 1. And then -1 we're plugging for y, but when -1 is squared, that is just 1. So this looks like that's just going to be 1/4 for the x component. For the y component, remember e to the power 0 is 1, and then x is 0. So that means that the second part of this is just going to go away. So it looks like that's just going to be 1. And of course, you can also compute that using a calculator. Okay, so we got the gradient. So let's just put that in there. We got it. Okay, so it says that the gradient, this guy, is the direction of the maximum rate of change. So if you want to walk in this direction and it's going to be as steep as possible, that's the direction to go. Now, what's the maximum rate? Well, it's the magnitude of the gradient. So what is the magnitude of the gradient? Well, we take square root, we take the first component squared plus the second component squared. So it looks like, let's just compute that. This is going to be 1/16 plus 1. That's going to be 17 out of 16. So this is going to be square root of 17/16. Now, which direction should we travel to get the maximum rate? Well, we already discovered that the direction should be the direction of the gradient. In other words, we're going to go in this direction. So we should just say the same exact thing in direction of the gradient. However, there's a little bit detail, and the detail is that they want it as a unit vector. So they want you to normalize it. Just make sure you don't normalize it when you answer this question, because if you normalize it and divide by the magnitude, the answer is going to be a unit vector and it will always have length of 1. That's not true. So you want the maximum rate is the magnitude of the gradient. Which direction? The gradient direction, which is this. But they want it normalized. I do not really understand why necessarily. Maybe because they just have a key and they want to compare and it should be matching exactly. So this was actually square root of 17 divided by 4. So when normalizing a vector, you divide by the magnitude. But when you're dividing by a fraction, it's the same as multiplying by the reciprocal of the fraction. So this is going to be just that right there. Okay, so the 4 here, 4 cancels. So the answer, if they want a unit vector, it will just be 1 over square root of 17 and 4 over square root of 17. And that should be our answer here. Okay.